Okay, fast forward it here. The existence of the derivative. So as we talked about in the most recent lesson, we talked about, well, when does the derivative exist and when does it not exist? So this is really important, being able to figure out what the graph of the derivative looks like. Okay, so the bottom line is the function has to be continuous at a particular point A. So in other words, let's go back. The derivative of a function f at a point x equals a exists. Okay, so we want to make sure we know that it exists if all of the following are satisfied. The function has to be continuous at that point x equals a, it has to be smooth, and it cannot have a vertical tangent, because remember, the derivative of a tangent line is the slope of the tangent line. So if the slope of the tangent line doesn't exist, which would be the case with a vertical tangent line, then the derivative doesn't exist. Okay, so those are the ones you got to be really careful about, because it's nice and smooth, nice and continuous at the vertical tangents, and so just be careful about that when you're graphing the derivative of a function. Okay, so let's fast forward here. We talked about these in our last lesson. Not continuous at a because it's, or not, the derivative doesn't exist at a because it's not continuous, it meaning the function. Not continuous at b, so not differentiable. Not differentiable at c, although it looks like it is, but there's a vertical tangent there. Not continuous at d, so derivative doesn't exist. The only time a derivative does exist at any of these points is at e. The derivative does exist because it's nice and smooth, no vertical tangent, and it's continuous there at e. Okay? And then again, here at f, we have a sharp point, so when the graph of f has a sharp point, the derivative doesn't exist there. Okay, let's move on.